Hello, my name is Ronald Ochoa. I am research entomologist of the Systematic Entomology Laboratory and a curator of the Smithsonian National Mite Collection at Pennsfield, Maryland. I work with plant-feeding mites at the United States Department of Agriculture. Today's presentation is an introduction to the family Tenuipalpidae. The Tenuipalpidae are commonly known as a flat mites or false spider mites. The family Tenuipalpidae has close to 40 genera described and more than 1,200 species known worldwide. The description in the body is very simple. There are all kinds of shapes and forms in the group. You have round, elongated, piriform, ovoid, triangular in the cross-section, and sometimes also flat in the venter or flat in the dorsum. And some of them are very thin also. There are between 250 microns to 400 microns in size. They could be red, green, yellow, orange. Here we have two females. You can see the difference in shape of the females. And also notice that on the left, or your right, it have a long H2 city when the one on the other side, number B, has all the cities the same size. In the case of the males, also we have different shape of the body. Some of them are very reduced in the opistosoma, and the other ones have a more triangular body. That means that in reality, just looking at the body and the color of the mites, we more or less can identify some possible genera. Some of them are really, really cool. For example, Euregersonis, the genus that you see in the top, you can see here three different ways to see the mite. The color one is with a stereoscope microscope in color. The one in the center is DIC, and the next one in black and white is a LTSEM. And you can get a very good idea how the mite looks and how thin is the body of this mite. In the lower part, you will see several Tenuipalpus mites. One of the most common mites that you know right now is Rauyella. Rauyella is the red palm mite. One thing that we discovered with Tenuipalpidae is that if we look very careful the immatures, also just looking at the immatures, we will know if you are looking at a possible female or a possible male. Here are the two protonymph, and already the protonymph, either one, are showing the shape, where indicate to me that this one on your right is a female in the future, and the other one, more pointed, will eventually be a male. In colors, again, all the rainbow. It's amazing the variation, tones, and colors of these mites. One thing that we are learning with flat mites are that they are very cryptic with the area where they feed, and they are very slow in movement. That means that usually when you grab your plants and you are looking for flat mites, you need to wait that the heat of the lamp start to hit the tissue that you are looking at, and that eventually made the mite to stand up and walk, because as you can see, camouflage is a quality for them. They are everywhere in all the continents, and some continents will have some specific genera, and others will have a more variation on this genera or will not have some of them. For example, the genus Brevipalpus is very common in the Americas and perhaps in Asia and part of Africa, but not in Australia. When in Australia they have several genera that are not present at all around other continents. The easy way to identify Tenuipalpidae is looking some morphological characters, like, for example, the palps. The palps are linear and they are in different shapes, and they do not have the palpal thumb claw system. Also, they have, as you can see, the palpal tibial without spine-like city. That is one of the characters. And also here we can see that the palpal segments often are reduced. The prodorsum with 3 pairs of ceti and 2 pairs of eyes. You can see here there is the V2, SC1, SC2, and you can see the eyes. The dorsal opistosoma with a maximum of 13 pairs of cities. F1 and H3 are absent in flat mites. As has been saying before, there are several systems used to identify disease over the body, but the most common one, and the one that I advise, is Grand-Jean system, C1, C2, C3, D1, D2, D3, E1, E2, E3, F2, F3, H2, H1. Here you also can see that the body are divided in regions, natosoma, propodosoma, opistosoma, and eventually some of them have plates, and some of them are more smooth. The series can be very striking. Sometimes the series, if you use a phase contrast microscope, you will have a hard time to identify what is city and what is body. Here, very clear, when we see this mite that is called isopalpus in comparison with the LTSEM photo on the right. Very, very adapted, very striking mite. I call this mite the Muppet mite. You can see the face there. Tenuipalpidae also have many different shapes of body and city arrangements. You can see these 3 different genera here. And if we want to see more detail, they are some that have very tiny cities, or some ones that they have a very striking fat cities, or other ones that have filiform cities in combinations with other shapes of cities. And some of them can be very beautiful, very gorgeous, as this mite from Egypt, associated with Phoenix dactylifera. Again, the part of the body, the ketotaxy, the presence of hysterosomal pores, the ventral plates, genital plates, lateral furrows, all that are important components to identify flat mites. As you can see here, we have 2 species here that have been before called the same name, Tenuipalpus phoenicis, but these 2 mites are completely different. If you look very careful, you will see furrows in this one, when in the other one you have straight lateral lines going to one side to the other side. Okay, the female genitalia usually is transferred in position and often is covered with a plate. Here, for example, you can see the genital region of a Royella mite. Now, a Tenuipalpus mite. You can see the ventral plate, genital plate, anal plate. There is a lot of details on them. One thing that is important to try to identify is the presence of the spermatheca inside the body. Also, you can see, for example, here the genital opening, and please notice the positions of some of the cities. For example, here, the G1 or G2. Males also give you characters, and also they have movement and different position of cities on them that can help you to identify the different groups, genera, and species. Tarsi is perhaps one of the most important part of the body of the flat mice. And you need to make sure that look careful, leg 1 and leg 2, as they have several solenidia. And the quantity and enrichment of the solenidia is key to separate some of the species and some groups. Here we can see Brevipalpus tarsus 2 with the 2 solenidia, and also we can see a Royella with 1 solenidia. Most pretarsi with a claw-like claws and pad-like impodium with tenon hairs. Tenon hairs are present. Sometimes they have a bunch of them, sometimes have very reduced numbers of tenon hairs. For example, this case of these Royellas, you can see that there are looks that they have only 1 tenon hair, but in reality, if you look in the base, you can see the 3 different pairs of tenon hairs coming together at the end. The tenon hairs also can be very useful. Some of the tenon hairs are longer in the outside area, and the inner ones are smaller, or sometimes are vice versa. The ones in the center are longer, and the ones in the outer part are slender and shorter. With that, we can go and see Also, the numbers of cities present in some of the legs. Here, I give you information about the tibia. Legs 3 and 4, each with a maximum of 3 city, and legs 1 and 2, each with a maximum of 6 city. Again, going over the solenidia, it's very important that you be aware of the solenidia and try to look at them. Here we can see several combinations. Some males in some males and some genera will have one solenidia in leg 3. Others will have in leg 3 and leg 4. Some of them will have 2 solenidia in leg 3 and leg 4. All these variations help you to identify the different groups in Tenuipalpidae and also the different genera. And important also when you are looking the legs of the flat mites is where the cities are located on the legs, if there are dorsal in position of dorsal or lateral position. We can see, for example, here with the arrows, you can see the 3 cities in Tenuipalpus that are in the lateral position. However, the same cities on Colopalpus and Brevipalpus are in dorsal position. Sometimes there are some surprises. For example, here we can see some adults that is still having just 3 pairs of legs. This is the case of Labarcarus, Phytotipalpus, and Rauliana. Some of them could be important. The most interesting part of the life cycle is that we have egg, larva, protonymph, deutonymph, and adult for females and males. However, it's important that the eggs, if you look at this series of photos of low temperature scanning electron microscope, you can see that the eggs are giving you characters, shapes, forms, size. And these can be used eventually for identified genera. Very colorful. Here you can see the complete colony with eggs, nymph, adults, males, females. The female is the darker one with darker color. The tail of the male and female. Many males mate with the adult females, but very often some of the males guard the deutonymph and are ready to copulate with the deutonymph when this one is molting to the adult. Feeding, slow feeding. They walk very slow. They often stay in the same area. They are feeding. They molt to the next stage. They keep feeding in the same area. They molt to the next nymph, and sometimes they molt to the adult, only feeding to just one section, one area. We don't know if it's one cell or not, but they are very slow in behavior. That photo that you see under the color one, we have the female looking backwards, but in reality it's not. That is the way that the mite is under the leaf often. And that is another thing that helps us to remember how they're located on themselves under the leaf and protect themselves and use the claws to grab the ground, sometimes grabbing the stomata and feeding on stomata, as the case of the genus Rauliana. They can feed in stems, fruits, they can produce galls. Some of them, they feed under the bark of some trees that they have a cambium. The damage also can cause browsing, and in some extreme cases, they can kill the plant. The stylet is well specialized, very long, one of the longest stylets in plant-feeding mites, and they are very sharp at the end. They can have 1, 2, 3 spines, and sometimes more than 15 spines in either side that help them to attach to the ground. And sometimes they have a little filter in the base that probably help the mite with the feeding, but also protecting the mite to not get particles from outside when they're feeding. Here are some colors of the photos. For example, Rauliana on coconut, you can see all that trees there completely yellow. And that is not because of mycoplasma or a virus or something like that. No, that is the direct feeding of the mite over the stomata. The other ones are orchid's leaf, and you can see the browsing caused by Brevipalpus mites. This one is very interesting. Here is a tree, you walk, you see the tree, you not see anything wrong. But when you grab the bark and you cut under the bark, there is a colony of mites. That means that there is still a lot unknown about feeding behavior of flat mites. They can come and move in any place, in any area. They can come by tourist people in some ornaments. They can come in tourist hats. They can come on plants, food. They are well adapted, and because they are so cryptid, are difficult to find. It's important to remember that we can use different systems to collect them: filter, watch, Berlet funnels, use lens to observe directly, and after that we can study them with different kinds of stereoscopes and microscopes to try to understand the morphology. Now, of all the Tenuipalpidae that we have been mentioned, there are 7 genera that for us are very important because they are shown often and they are major economic pests. There are in the genus Brevipalpus, Xenopalpus, Tenuipalpus, Pentamerismus, Rauiella, and Dolichotetranaicos. The genus Brevipalpus have close to 300 species right now. There are 3 major groups: Phoenicis, Obobatus, and Californicus. The body, as you can see, is oval. They have opistosoma kind of pointed at the end. They have the pores. They have cities. One of the groups have F2, F3. The other 2 groups have only F3. There are close genera also, close to the genus Brevipalpus, and these ones are Amblipalpus, Xenopalpus, Priscapalpus, Colopalpus, and Terminalicus. Brevipalpus have all the plates: ventral plate, genital plate, anal plate, and that is a very easy character to identify when you are dealing with a Brevipalpus. However, always keep in mind to find immatures. The immatures will give you extra information. They have 4 pair of legs in the case of the Deutonymph, and the CD shape around the opistosoma is really important to help you to separate some of these species. Xenopalpus. There are 60 species of Xenopalpus. The 3 most important are Xenopalpus lanceolaticeta, Xenopalpus pulcher, and Xenopalpus spinosus. The body is more rounded in comparison with Brevipalpus. In reality, it looks stronger. The tegumen is more compact, and they have extra city in comparison with Brevipalpus. They have the C2 city. Here you can see a close-up of the city C2, and also you can see here the drawings of Xenopalpus pulcher. Xenopalpus pulcher is present already in the United States, only in the state of Oregon on apples, but also is in Argentina, in the areas where they grow apple too. The females survive winter as a diapause stage. The genus Tenuipalpus, that one also is very important. This is a very colorful genus. Many shapes, many colors, probably several genera inside it. The body with a proposoma distinctly wider in the front and more narrow in the back. They have a protuberance of fins over the body also too. The legs, the claws, do not have a true claw. They are only pad-like, no presence of a true claw on the legs. There are 3 genera close to it: Lysapalpus, Ultratenuipalpus, and Urigarsonus. Here you can see photos in color of the Tenuipalpus that are more or less lateral view. Look how nice are that protuberance over the body. And here at the tail one of it, they are so robust, so strong, that almost we can say that we're looking at Schwarzenegger palpus with big, strong muscles. And you can see the microplates. The microplates are that cinnamon rolls that you see there in the bottom. And that is an interesting character that we found in low temperature scanning electron microscope. Maybe it's a lot to learn about Tenuipalpus. And I'm sure many of them will be important pests in ornamentals. One of it, well known, is Tenuipalpus pacificus, that is important pest on orchids. Here we can see a very nice photo of a big population on them. There is a new mite in the neighborhood. This already shown in Brazil, Costa Rica, a couple of islands in the Caribbean, and here in Florida, Tenuipalpus ubae, that is associated with Spondias purpurea. It's kind of a prune, Spanish prune, I think is the common name. Very interesting. Look at the immatures. Look how oval strong are that immatures. Pentamerismos is another genus that is important, especially when it is associated with forestry. They are associated with many different trees, conifers in special. There are several genera also that are very similar to Pentamerismos: Agiopta, Capedulia, Obdulia, Phylotetranicus, Phytopipalpus, Pseudoleptus, Raweliana, and Tenuilicus. Here we have two very important species, Pentamerismos erythraeus and Pentamerismos oregonensis. These three species are in the area. Raweliella. Raweliella is one of the fastest spread invasive species of the American continent. There are several species well known: Raweliella indica, australica, Macfalieni, Eugenie, Pandane, and Chimpana. Of all of them, only indica attacks or affect palms, and this one has been dispersed from Florida to Brazil. The body is more or less oval. However, when you do the slide and you mount it, you tend to make the body rounded, and that is a complete artifact of mounting process. Here you can compare the real mite on a stereoscope. You can compare against the DIC mounting or the LTSCM. As I mentioned before, all the Raweliella mites fit across the stomata. And interestingly, they produce liquid that is coming from the body up to the top of the cities. This liquid, in base of conversations with Dr. Jose Carlos Rodriguez, apparently is associated as a defense mechanism. The liquid also could be used for identification of species. As you can see, all these 6 species as you can see, all these 6 species here. On the right, you can see Raweliella indica, and compared to the other 5 other species that have different tones of colors of the liquid of the top of the series called droplets. And the colors can be amber, hyaline, orange, and perhaps could be used as a characteristic to separate species affecting eucalyptus in this case. The last genus, Dolichotetranicus, is a very interesting genus as it's associated with monocotyledon plants. One of the most well-known is the one that attack pineapple. They feed in the base of the leaf and cause a slow death of the plant. The bodies tend to be long to slender, and it has several series, including D3 and sometimes E3. There are several close genera: Acariasis, Afronicus, Coleacarus, Ovuloides, Prolixus, and Tenuipalpus. It's a very striking mite, very colorful, usually very strong red colors. There is a website that you can go and get more information. It's called the Flat Mites of the World. In the Flat Mites of the World, you will find information about flat mites. You will find what it is a flat mite. You will also have information about how to mount it and prepare these mites, and what kind of microscopy system you need to use to study the mites. I thank the people that helped me to prepare this material. Questions? Yes.
Since tenuipalpids are so cryptic, can you suggest your favorite collection technique that we could use on the inspection floor?
Flat mines are easy to collect using sieves and washing the material. But the easy way will be direct inspection with the stereo microscope or with a lens over the tissue.
What are some characters you can use to distinguish the genera Tenuipalpus and Brevipalpus?
The genus Tenuipalpus and Brevipalpus are very similar. However, Tenuipalpus is easy to separate from Brevipalpus by the filiform city H2.